Welcome to Orbit Observer. Settle in wherever you are tonight. Let your shoulders drop away from your ears, let the light go low, and let the day you have been carrying begin to loosen its grip, because there is nothing here that needs solving, nothing you have to keep hold of, only a quiet story to sink into while the rest of the world goes dark below you. There is a mountain of rock, roughly 5 kilometres across, that has kept pace with Earth since before you were born. It has been out there your whole life. It was out there when you were a child, lying awake with questions no one quite answered, and it is out there right now, moving through the same patch of sunlight we move through, quietly matching our stride across the solar system. And almost no one knows its name. Think about that for a moment, softly, the way you might turn a smooth stone over in your hand. Not a car-sized fleck of debris that drifts past for a season and is gone. Not a pebble caught for a few months and then let go. A genuine mountain. Something that, if you could stand on it, would rise around you in cliffs and slopes and long shadowed valleys of stone. A small dark world of its own, and it has been travelling beside us the entire time, keeping a distance and keeping a rhythm, and hardly anyone has ever heard what it is called. Its name is Cruithne. You will hear it said a few different ways, something close to Cruithne, and it belongs, as a name, to an ancient people of Britain and Ireland. A deep and old human word, carried now by a deep and old companion in the sky. But before we sit with the name, before we walk out into the dark to meet it, let me set down gently what this story is, and what it is not. You may have seen the headlines. Every so often they come around again, breathless and bright, announcing that Earth has a secret second moon, that a hidden companion has been discovered, that there is something out there they never told you about. And there is a small, understandable thrill in words like hidden and secret, a little pull that makes you want to lean in. But I want to take that word, hidden, and turn it very slowly in the light until it means something calmer and, I think, something far more wonderful. Because there is nothing here that was kept from you. There is no plot, no cover-up, no shadow planet hiding behind the sun. There is only a quiet, honest fact that simply never made it into the stories most of us grew up with. A real mountain of rock has been keeping perfect pace with our planet, and the only thing hidden about it is how few people ever paused to look. That is a softer kind of secret. The kind you get to keep, tonight, and fall asleep holding. So let us go back to the beginning of how we came to know it. Let us go back to the 10th of October, 1986. Picture, if it helps you drift, a mountaintop in the dry heart of Australia at a place called Siding Spring Observatory. Picture the enormous quiet of a night sky out there, far from any city glow, the kind of dark that feels less like an absence of light and more like a presence all its own, thick and close and full of stars you never see from town. And picture a telescope called the UK Schmidt, a great instrument built to sweep up wide swathes of that sky and lay them down on photographic plates. Sheets of glass coated so they could catch the faintest whisper of starlight over long, patient exposures. This was before the world went digital. The sky was still being recorded on glass and emulsion, one careful frame at a time, and then studied later by human eyes bent close over the developed plates, hunting for anything that had moved. On one of those plates, taken that October night, there was a faint dot. Nothing dramatic, nothing that announced itself. Just a small point of light among countless others, the sort of unremarkable smudge that the sky is absolutely full of if you look long enough. It was an astronomer named Duncan Waldron who found it, working with the images from that Schmidt Telescope. And at first it was simply another moving speck to be logged and measured, given the plain provisional label that every newfound object gets before anyone knows quite what it is. They called it, at first, 1986 TO, a placeholder. A little tag pinned to a stranger until it could be properly named. And here is the part I love, the part worth slowing right down for. On that night in 1986, no one watching knew what they had. They had photographed a dim wandering point of light, one among many, and filed it away. It would take another 11 years, more than a decade, before anyone realized that this faint dot had been walking beside the Earth the entire time. 11 years between seeing it and understanding it. Sometimes the most faithful thing in your life is standing right beside you, and it still takes you years to turn your head and truly notice. But we will come to that understanding in its own time. Tonight there is no hurry. Let the discovery just sit there for now, a speck on a glass plate in the Australian dark. Quietly holding a secret it was in no rush to tell. Once its orbit was traced and confirmed, the placeholder gave way to a proper designation and a proper name, and so 1986 TO became 3753 Cruithne. The number is simply its place in the long, ever-growing catalogue of small worlds we have found drifting around the sun. The name is the gift an ancient people lent to an ancient traveller. Now let me give you a sense of its size, because this is where Cruithne quietly separates itself from all the noise, from every fleeting headline about a temporary second moon. Because most of those stories, when you read past the first line, turn out to be about something very small indeed. A rock the size of a car. A boulder the size of a small house. Something that swings close to Earth, gets tangled briefly in our gravity, loops around for a few months or a couple of years, and then slips away again, forgotten almost as soon as it was found. Those little visitors are real, and we will meet a few of them later, gently, further along in the night. But they are fragments. Passers-by, guests who stay for a season. Cruithne is not that. Cruithne is estimated at around 5 kilometres across. 5 kilometres. Hold that number in the dark for a moment and let it grow to its true size. That is not a boulder you could photograph tumbling past. That is a mountain. That is a body large enough that, standing at its base, you could not see its far side. A small dark landscape of stone drifting through space, orders of magnitude larger than the car-sized specks that make the excitable news. It is a genuine world, humble and unlit and utterly silent, and it has been our travelling companion for far, far longer than any of those brief visitors ever managed. If the little rocks are guests who stay a season, Cruithne is something closer to a neighbour who has been there all along, at the edge of the view, keeping their own quiet hours, for your whole life and for lifetimes before yours. And I find myself wondering, as we settle in tonight, where in the world you are hearing this. Whether it is late, where you are, the house gone quiet, or whether the dark came early and you have simply pulled the covers up against a long evening. If you feel like it, before you drift too far, tell me down in the comments where in the world you are listening from tonight. I genuinely like to know. It is a strange and lovely thing to think of all of us scattered across this one planet, all of us being paced by the very same silent mountain of rock, all of us looking up in our different time zones and our different weathers at the same patient sky. And if you are new here, if you have only just found this quiet corner of the night, you are very welcome to stay. Settle in, follow along, and let this become one of the places you come to when the mind will not stop turning and you need a calm voice to carry you down towards sleep. Because here is the question I want to leave gently glowing in the dark for you, the one we will spend the rest of this slow journey answering, so there is no need to chase it now. You have heard, tonight, that a 5-kilometre world keeps pace with Earth, and your mind, even half asleep, may have already reached for the obvious word. A companion that big, that faithful, that constant, moving right alongside us, year after year, century after century. Surely that is a moon. Surely that is exactly what a second moon would be. And yet the astronomers, after that 11-year wait, after they finally understood what they were looking at, chose their words with great care. For a brief while, in the wake of that understanding, some did call Cruithne Earth's second moon. The phrase spread, the way exciting phrases do. And then, quietly, deliberately, they took it back. They walked the word moon away from Cruithne, not because the object was any less real, and not because it was any less faithful, but because the word itself, that simple familiar word, turned out to be quietly, precisely, beautifully wrong. So that is where we are heading, in no hurry at all, over the slow hours ahead. If this mountain that has paced us our whole lives is not a moon, then what, exactly, is it? How can something so large stay so near for so long and never once come to us? Let the question rest lightly. We will walk toward the answer together, one gentle step at a time, and there is nowhere else either of us needs to be. To understand what Cruithne actually is, you have to begin with the sun, not with Earth, not with the moon hanging white and dependable outside your window. Begin with the sun, and with the slow, ancient business of orbiting it. Everything in this story comes back to that one fact, offered plainly: Cruithne orbits the sun. Not Earth, the sun. And that single sentence, held quietly for a moment, is the key that unlocks everything else about this companion that has walked beside us for centuries without ever being what we thought it was. Think of it this way. The Earth takes 1 year to complete its great circle around the Sun, 365 days more or less, and we are back where we started, having swept through roughly 940 million kilometres of space without noticing most of it. We do not feel the journey. We only see its ghost in the slow wheel of the seasons, the way the light changes in autumn, the way the cold comes and then goes. But the orbit is real, enormous and continuous, and it takes us exactly 1 year. Now, Cruithne also takes 1 year to orbit the Sun. Not quite exactly 1 year, but close enough that the difference, measured in days, is less than a single day. Its orbital period is roughly 364 days, barely a whisper shorter than ours. And that coincidence, that extraordinary timing, is not really a coincidence at all. It is the mechanism. It is the entire reason this 5-kilometre mountain of rock has kept pace with us across centuries and will keep pace with us across centuries more. The two of us, Earth and Cruithne, lap the Sun in almost the same time. So Earth never catches up to Cruithne, and Cruithne never falls behind Earth. They simply travel, year after year, holding station, maintaining their strange companionship, not because one is tethered to the other, but because they move to the same slow clock. Astronomers have a name for this. They call it a 1-to-1 mean motion resonance, or a co-orbital resonance. The language sounds cold when you write it out like that, but the image it holds is not cold at all. Imagine two people walking a long, circular track, both covering exactly one lap in exactly the same time. They might be far apart, on opposite sides of the track. They might be close, separated by only a few meters. But they will never gain on each other, and they will never fall back. The rhythm of their steps is matched, and so they travel together, even if they never meet. That is what Cruithne and Earth are doing. That is what they have been doing for longer than any record of human civilization. But here is where it becomes genuinely strange and genuinely beautiful, because the paths the two of them trace around the Sun are nothing like each other. Earth's orbit is very nearly a circle. If you drew it on a piece of paper, it would look smooth and even, an almost perfect ring around a central point. But Cruithne's orbit is something else entirely. It is stretched, elongated, pulled into a long ellipse, the shape of something squeezed at both ends. The technical word for how elongated an orbit is happens to be eccentricity, and if a perfect circle has an eccentricity of 0, then Cruithne's orbit has an eccentricity of roughly half of 1, about 0.51, which means it is dramatically, visibly not circular. It swings far in toward the Sun, and then out again to a much greater distance, tracing a path that looks almost nothing like Earth's patient, even ring. And then there is the tilt. Earth's orbit sits on a plane, the flat table around which the planets generally agree to travel. Cruithne's orbit is inclined to that plane by roughly 19.5 degrees, which means it cuts through and above and below the plane of Earth's journey, like a road that climbs and dips rather than staying level. When you picture these two paths together, Cruithne's wild, tilted ellipse and Earth's quiet circle, they look nothing alike. They belong to different ideas of how to move around the Sun. And yet, somehow, impossibly, they take the same amount of time. The eccentric, plunging, angled path and the calm, circular path arrive at the same rhythm, and that shared rhythm is what binds them. Earth never laps Cruithne. There is no gravitational leash, no invisible rope from our planet's centre to this rock. If you were to somehow remove all of Earth's gravity from the equation, Cruithne would still complete its orbit in roughly 364 days. The companionship is not held together by force, it is held together by timing. And timing, it turns out, is its own kind of faithfulness. Now here is something worth holding for a moment, in the unhurried way that is the only way anything wants to be held at this hour. The object was discovered in 1986. Duncan Waldron, working with photographic plates taken at the UK Schmidt Telescope at Siding Spring Observatory in Australia, found the faint moving point on the 10th of October of that year. It was catalogued, given a provisional designation, logged as 1986-2, and filed among the growing register of near-Earth asteroids. That was the sum of it, at first. A dot, a data point, a number, and then 11 years passed. 11 years during which Cruithne continued its 364-day circuit around the Sun, continued its slow companionship with a planet that had no idea what it was looking at. 11 years in which no one quite worked out the shape of the dance being performed just outside our door. It was not until 1997 that 3 astronomers, Paul Wiegert, Kimmo Innanen, and Seppo Mikkola, published a paper explaining what Cruithne was actually doing. Not just that it was a near-Earth asteroid, not just that its orbital period happened to match Earth's, but something far more intricate, far more surprising, and far more difficult to picture without some patient guidance. What they described was a horseshoe orbit. And we will come to that in full, because it deserves to be felt rather than merely stated. But for now, let the gap sit with you for a moment. 11 years between the first photograph of a faint dot and the understanding of what that dot was doing. 11 years of Cruithne going about its slow business, coming near and drifting back, tracing its ancient path around the sun, while the telescopes that found it pointed elsewhere and the calculation remained undone. There is something very human in that. We see a thing long before we understand it. We name it before we know it. We file it away and return to it later, sometimes much later, when someone finally has the patience and the tools to ask the deeper question. And the name. Let us stay with the name for just a moment, because it is not accidental, and it is not small. Cruithne. It is pronounced something close to Cro-o-in-u, or sometimes Crin-u, depending on whose mouth it passes through, and the word itself is old, very old. The Cruithne were an ancient people of Ireland and Scotland, associated in the historical record with the Picts, one of the early peoples who inhabited the northern reaches of Britain before the layers of history and invasion and change accumulated over them. They are not a civilization most people could tell you about in any detail. They are something older and quieter than the names most of us learned in school, a people whose traces are still faintly readable in certain place names and certain stones, but who are largely lost now to the long distance of time. And so someone, at the moment of naming, reached back across that distance and laid an old human name on a very old piece of rock, a deep time name for a deep time companion. A people who lived and moved through a particular part of the world for centuries, who are now mostly unknown to the world that came after them, assigned to a 5-kilometre world that has moved beside our planet for centuries, largely unknown to the civilization that shares its sky. There is a kind of quiet poetry in that pairing, if you let yourself hear it. The forgotten people and the unrecognized companion. Both ancient, both still here, in their way, both carrying their own kind of faithfulness across a very long span of time. So here is where we are, at this point in the journey, on this slow and unhurried night. Cruithne orbits the Sun. It takes roughly 1 year to do so, just as Earth does, and that shared timing is the whole of their kinship. Not gravity, not tether, but rhythm. Its path is wild and tilted and nothing like ours, and yet the clock it keeps is our clock. It was found in 1986, a dot on a photographic plate, and it was not understood for another 11 years. When 3 careful astronomers finally traced the shape of what it was doing. And it carries the name of a people who inhabited the ancient north, a name as old as the question of who came before us on this particular island of land in the sea. That is what we know. That is the foundation. And now we are ready to walk toward the shape of the dance itself. Because that is where the real strangeness lives, and the real reassurance, and the reason that even the word companion feels almost too small for what Cruithne actually is, once you can picture the path it has been tracing, year after year, through all the years of your life, and long before it. There is a way to imagine it that makes the whole thing visible at once, and once you have it, you will not lose it. It requires only that you step out of your usual position, standing on Earth, looking up, and into a different one. Imagine instead that you are floating somewhere above the plane of the solar system, watching the Earth move around the Sun, and that you are turning slowly, always keeping Earth at the center of your view, always rotating just fast enough to match its pace around the Sun. You are, in other words, riding along with Earth in your imagination, keeping it still in the middle of your field of vision while everything else continues to move. And from that vantage point, which astronomers call the rotating frame, you can finally see what Cruithne is doing. You can see the shape of the dance. It does not circle Earth. That is the first thing. There is no orbit, no loop that closes around us, no path that brings it around behind, and then forward, and then around again, the way the moon swings around and around and around without end. None of that. What you see instead from this rotating frame is that Cruithne traces a loop, a rounded, elongated shape. Something between a bean and a kidney, wider at the ends than the middle, and it traces that loop once each year, in rough synchrony with the seasons, because it is completing its own lap of the sun in the same roughly 364 days it takes Earth to complete ours. Once a year the bean, once a year the loop. And then again, and again. This is already remarkable in its quiet way, a 5-kilometre mountain of rock, tracing a closed shape in our sky, year after year, driven by the geometry of two bodies sharing a clock. But the bean is not the whole picture, it is only the year-to-year detail. Step back further in your imagination and watch across decades, and then centuries. The bean does not stay in one place. It drifts. Slowly, patiently, almost imperceptibly, year by year, but over the long stretch of time, undeniably, the bean slides along a much larger path, a vast, curved track that looks. If you smooth out all the individual loops and think only of the general direction of travel, like the inside of a horseshoe, an enormous horseshoe, opening toward Earth, but never closing around it. And Cruithne is moving along the inside of that horseshoe, drifting from one end toward the other, and then, eventually, back again in a rhythm so slow that one complete transit, from one tip of the horseshoe to the other and all the way back, takes on the order of several centuries. Astronomers who have run the simulations carefully put that full sweep at roughly 770 to 800 years, though this is a figure derived from orbital modelling rather than direct observation. And the exact number shifts a little depending on the precise initial conditions used in the calculation. But the shape of it, centuries, not decades, a rhythm measured in generations, not in years, that part is robust. Now here is the piece that matters most, the piece that answers the question you may already be half-forming, which is, what happens when the drift brings Cruithne toward Earth's side of the horseshoe? What happens when it gets close? The answer is one of the most quietly beautiful things in orbital mechanics, and it rests on a principle so simple that once you hear it, it stays with you. When Cruithne is far from Earth, on the opposite end of the horseshoe, it is moving around the sun at its own pace, undisturbed, but as the centuries carry it drifting along the inside of that vast curve, it begins to approach. Slowly, incrementally, the gap between its bean-shaped annual loop and the position of Earth begins to narrow. And Earth notices. Not with awareness, of course, the Earth does not notice anything, but gravitationally. Its gravity begins to reach toward Cruithne, tugging gently. And here is where the geometry becomes the protection. When Cruithne is approaching Earth from behind, coming up, as it were, from the slower end of its orbit, Earth's gravity pulls it slightly forward, and pulling it forward means accelerating it, and accelerating it in that particular direction in the context of an orbit around the Sun means giving it a tiny boost of speed, which in turn pushes it into a slightly higher, slightly wider orbit. A wider orbit takes longer to complete. So the period of Cruithne's loop, which was almost exactly matched to Earth's, becomes by the smallest of margins a little longer. And that means, in the following year, Cruithne falls slightly behind, and the year after that, slightly further behind. The approach reverses. The drift turns around. Cruithne retreats, not because anything pushed it away, not because Earth repelled it, but because the very act of receiving a gentle gravitational nudge in exactly the right direction changed the period of its orbit just enough to halt the convergence and reverse it. The wall at this end of the horseshoe is made entirely of gravity, and it is, in every meaningful sense, impenetrable. The same thing happens at the other end of the horseshoe, in mirror image. When Cruithne is approaching from the far side and Earth's gravity begins to reach it again, the tug in that geometry has the opposite effect. It slows Cruithne slightly rather than speeding it, which drops it into a lower, faster orbit. And so now it begins to lap Earth rather than fall behind, and the drift once again reverses, and once again the wall holds. This is why the horseshoe never closes. This is why the approach always turns into a retreat. The same force that draws Cruithne near is the force that sends it gently back. So when you ask how close it gets, the answer is close in astronomical terms, and yet extraordinarily, reliably safe. At its nearest, when the drift has carried it to the Earth-side tip of the horseshoe, Cruithne comes within roughly 0.08 astronomical units of Earth. 1 astronomical unit is the average distance between the Earth and the Sun, roughly 150 million kilometres. 0.08 of that is somewhere in the region of 12 million kilometres. That is, to put it in a scale that means something, about 30 times the distance between the Earth and the Moon. 30 moons, stacked edge to edge in space, would span the gap at closest approach. In human terms, this is an almost incomprehensibly large distance. The closest any human being has ever travelled from Earth is the Moon, and that journey across a mere 384,000 kilometres required 3 days of powered spaceflight. 12 million kilometres is an entirely different order of magnitude. It is not nearby. It is not threatening. It does not brush past us. It simply drifts, slowly, through a region of space that is still immeasurably vast by any standard that matters to a person lying in bed, and then it turns, and it goes. And it has been doing this for a very long time. Long-term simulations of Cruithne's orbit, careful calculations carried out by tracking the gravitational influences of all the major bodies in the solar system and running them forward and backward through time, suggest that the present horseshoe configuration is stable on a timescale of thousands of years. Not centuries. Thousands. The dance it is tracing now is not a new arrangement that happened to form recently and will dissolve just as quickly. It is an ancient pattern, older than anything we have written down, older in all likelihood than the languages in which we ask questions about it. Cruithne has been tracing some version of this horseshoe for an enormous span of time, and absent any significant perturbation, the simulations say it will continue for thousands of years more. There will eventually be disruption of a kind, but not from Earth, and not on any timescale that belongs to us or to our children or to any number of generations we could plausibly count. Venus is the likely agent of eventual change. As Cruithne's eccentric, steeply tilted orbit carries it through the inner solar system, it passes through the gravitational neighbourhood of Venus on timescales that, run far enough forward, begin to accumulate. Close encounters with Venus in the distant future may gradually reshape the horseshoe, nudging Cruithne's period off its resonance or altering the tilt and eccentricity of its path enough to break the pattern. But this is the very far future, measured not in any human unit, but in the deep time of the solar system itself. For every practical purpose, for every night of your life and your children's lives, and every life that will follow in any span of time that imagination can comfortably hold, Cruithne will continue its slow, vast, patient horseshoe, drifting toward us over the centuries and then turning gently back. So that is the shape of it. The bean, traced once a year in our rotating frame. The horseshoe, traversed in centuries. The gravitational wall that turns each approach into a retreat without anything ever touching. Without any force that could be called repulsion. Without any drama. Just the quiet, self-correcting geometry of two bodies sharing a clock, regulated by the same invisible field that holds the moon in place and keeps the tides moving and makes the weight of everything you have ever held feel like something. Gravity, turned not into a chain or a collision, but into a perpetual, gentle turning away. An eternal, almost arrival. There is something restful in that, once you feel it. Something that loosens a small knot you may not have known you were carrying. Because the question underneath the question, beneath the curiosity about horseshoe orbits and resonance and astronomical units, is always the older, simpler one. Is it safe? And the answer, built into the architecture of the solar system itself, woven into the mathematics of how orbits work, is yes. It has always been safe. The shape of the dance guarantees it. And yet, before you let that rest settle fully, there is one last thing worth naming, a small gift of clarity that the astronomers had to sort through themselves, and that is worth walking through together here. Slowly, because it is the piece that makes the whole picture finally make sense. It is the question of what precisely Cruithne is. Not in the colloquial way, not in the headline way, the Earth's second moon way that swept briefly through popular science writing in the years after 1997, but in the careful, honest, structurally correct way that actually makes the story more wonderful, not less. The word moon is doing a very specific job in astronomy. A moon is a body gravitationally bound to a planet, circling that planet. Our moon, Luna, the one you have watched rise over rooftops and fields and water your whole life, orbits Earth, not the sun. Earth, it is tethered to us in the most direct possible sense. If Earth were somehow removed from the solar system, the moon would have to find another home, because it has no independent solar orbit of its own, not in any practical sense. That is what moon means. That is the definition the word is carrying. Cruithne does not satisfy it. Cruithne orbits the sun, always has, always will. It is not tethered to Earth. If Earth were somehow gone, Cruithne would simply continue its elongated, tilted, 364-day loop around the sun, alone, no longer keeping pace with anything in particular. The gravitational bond the word moon implies simply does not exist between Earth and Cruithne. And so when astronomers walked back the second moon label after 1997, they were not being pedantic. They were being precise in the way that precision is actually useful, because the correct description turns out to be stranger and more interesting than the wrong one. What Cruithne is, properly, is a horseshoe companion, a co-orbital body, a world that shares a rhythm without sharing an orbit, that keeps perfect time with Earth the way two musicians in separate rooms can play the same tempo without ever being in the same space. The 1.1 mean motion resonance is the metronome. The horseshoe is the shape the dance takes when you draw it out and watch it over centuries. Neither of those things is a moon, and both of them are more precise and more evocative than the word they replaced. But Cruithne is not the only member of Earth's quiet retinue, and the others are worth knowing, because they each represent a different way a world can accompany our planet without being its moon. The closest thing to a moon that Earth currently has, besides the moon itself, is a body called 469219 Kamo Alewa, also catalogued as 2016 HO3. Discovered in 2016 by the Pan-STARRS survey operating from Hawaii. Kamo Alewa is a quasi-satellite, a quasi-moon. That is a different arrangement from Cruithne's horseshoe. A quasi-satellite does orbit the Sun, as Cruithne does, but its particular combination of orbital period and shape causes it to appear, when viewed from Earth's rotating frame, to loop slowly around us once a year. Not a true orbit, not a closed ring around Earth, but a looping, accompanying spiral that from our perspective looks almost like the real thing. Kamo Alewa has been doing this for centuries and will continue for centuries more, making it, by that measure, Earth's most stable current quasi-satellite. It is small, roughly 40 to 100 meters across, somewhere in that range, which gives a sense of what car-sized means when scientists use it. Because 100 meters is perhaps the size of a modest city block. Not tiny, but nothing like the 5-kilometre mountain that is Cruithne. And yet Kamo Alewa carries inside it a mystery that may be one of the most quietly astonishing facts in planetary science right now. When astronomers examined its spectrum, the fingerprint of light it reflects, which can tell you something about the minerals on its surface, they found a reddened silicate signature that closely resembles the lunar samples brought back to Earth by the Apollo missions. The light coming off Kamo Alewa looks, in that specific technical sense, like the light that comes off the moon. What this suggests, and it is a hypothesis, a leading and peer-reviewed one, not yet settled fact, is that Kamo Alewa may be a fragment of Earth's own moon. A piece of lunar, broken off by some ancient impact, perhaps hundreds of millions of years ago, that drifted into its own solar orbit and gradually settled into the quasi-satellite configuration it holds today. The moon, in other words, may have left us a calling card, a piece of itself, wandering alongside us in a different kind of relationship than the rest, close enough to study, carrying the chemical memory of where it came from. China's Tianwen-2 mission is currently making its way toward Kamo Alewa to collect a sample and bring it home. The first time a piece of a quasi-moon will be returned to Earth for direct analysis. Whatever those samples contain, they will either confirm the lunar fragment idea or complicate it in ways that will take years to fully understand. The answer is genuinely pending. The question is open in the most literal sense. A spacecraft is in transit right now, and the rocks are waiting. Then there are the Trojans. Earth's Trojan asteroids, 2010 TK7, which was the first of them to be confirmed in 2011, and 2020 XL5, ride the Lagrange points, which are positions in space where the gravitational influences of the Sun and Earth balance in a way that allows a third object to remain stable. The L4 and L5 points sit 60 degrees ahead of and 60 degrees behind Earth in its orbit around the Sun, and they have been called gravitational parking spaces, which is a useful image, though the real situation is a little more dynamic than that phrase implies. Jupiter has thousands of Trojans. Earth has, so far, 2 confirmed. They do not horseshoe. They do not quasi-orbit. They simply ride the stable points, 60 degrees away, like quiet outriders, keeping a fixed distance from the caravan. And the newest addition to the catalogue, 2025 PN7, a small near-Earth co-orbital identified only recently. One of the most recently noted companions in Earth's retinue and still being characterized as observations accumulate. The family is growing. Every year or two, a survey catches another faint dot in a particular kind of orbital relationship with Earth, and the list quietly lengthens. Cruithne was the first of them to be understood, the first whose strange companionship was mapped and described. But it was not the last, and it is not alone. What is striking, when you hold all of them together, the Horseshoe companion, the quasi-satellite, the Trojans, the temporary mini-moons that drift in for a season and then drift away, is how many different textures of companionship are possible in the architecture of orbital mechanics. The temporary mini-moons, bodies like 2006 RH120 and 2020 CD3 and 2024 PT5, are the brief visitors, small objects, usually car-sized or smaller, that wander close enough for Earth's gravity to capture them loosely for a few months or a couple of years, then release them back into independent solar orbit. Visitors, not residents, they come and go on timescales a human could watch unfold across a news cycle. Cruithne is something else. Cruithne is the resident, not a captured satellite, not a temporary guest, but a companion in the precise sense. A world that has kept pace with Earth across a span of time so long that the human presence on this planet barely registers as a fraction of it. The horseshoe it traces takes on the order of 770 to 800 years to complete one full sweep. Civilizations rose and fell while Cruithne was making its way from one end of the horseshoe to the other. The mathematics that govern its path were not written by human hands. They were set in place long before there were hands to write anything. And they will continue long after, in some form, on their own slow, patient schedule. This is the thing that is worth lying still with for a moment, as you settle into wherever you are. Somewhere out there right now, not metaphorically, not as a way of speaking, but literally, physically, measurably, tracked by JPL, catalogued and numbered and named, a 5-kilometre mountain of rock is completing another small portion of its centuries-long horseshoe. It is doing what it has always done. It is keeping pace. It will come nearer over the years and decades ahead, and then it will feel the gentle regulation of the shared gravitational field, and it will slow and turn and begin the long drift back. It will not touch us. It cannot. The geometry prevents it in the most fundamental sense, the way a ball rolling in a curved bowl cannot climb out of the bowl, not because something stops it actively, but because the shape of the space it moves through will not permit the outcome. And the name it carries, Cruithne, belongs to an ancient people, an early people of Britain and Ireland, a name from the deep past of this island that has looked up at the same night sky you are looking up at now, or resting beneath, or half sleeping under. A human name, given by human hands, to something that was keeping pace with those same humans long before any of them had words for what they saw moving slowly across the dark. You have been quietly accompanied your whole life, not in the way of a moon, not circling, not tethered, but in the way of something that shares your year and your path and your long, slow ride around the sun, and asks nothing of you in return. It does not need to arrive. It has never needed to arrive. The companionship is in the keeping of the rhythm, in the long, faithful pacing, in the centuries of approach and turning away that add up to something that has no single human word good enough to hold it. So if you feel like sharing where in the world you are listening from tonight, the comments are there, and I read them. Every location, every time zone, every different sky above a different patch of ground. It matters, knowing where the quiet reaches. There are more stories like this one here, slow and careful and true, waiting for whenever you want them. You have done enough for one night. Let the horseshoe turn without you for a few hours. Let Cruithne keep its patient watch while you rest. Good night from up here in orbit. I'll keep watch while you drift.